Hi, I am Sherin Beevi, Assistant Professor in CSE Department from RMD Engineering College. Discussed about the topic is minimum mode configuration in 8086 microprocessor. So minimum mode. So 8086 one of the processor, it is operated in minimum mode. So here minimum two different types of mode operation. One is minimum mode and another one is maximum mode. Minimum mode means only one processor to control all the memory devices and I/O devices. Maximum mode means one or more processor to control of all the devices like memory and I/O devices. So here minimum slash maximum bar. So we are giving the 1 as the input mean 1 slash maximum bar. So 1 bar. So 1 slash 1 bar means it is a 0. So we are giving as a logic C1 means acting as a minimum mode operation. We are giving logic 0 means acting as a maximum mode operation. So here all the control signals mean it is a read and write signal are given out by the microprocessor chip itself. So we are giving 0. So here this operation is memory slash IO operations. So different types of interface, memory mapped IO interface, IO mapped IO interface. So memory 0 as a input means 0 slash IO bar. So 0 bar. So 0 slash 1. That is the answer. So we are giving as a 0 as a input IO operation. We are giving 1 as the input, 1 slash 1 bar means 0. So 1 means to read or write from the IO devices. 0 means read or write from the IO devices. So here under the value of 0 as the IO operation, 0, 1, 1, 0. So 0 means this is the read bar. Here this is the write bar. So 0 means 0 bar is 1. So IO read, here IO write. Here 1 means as a memory, 0 bar. So memory read and memory write. So it support 4 different types of components: latches, transceiver, clock generation, memory and IO devices. What is latches? Latches means it is acting as a buffer. So comparing to the latches and the flip-flop it is executed with the help of the clock pulses. So D flip-flop, number of flip-flop already we studied from the DPST subjects. And D flip-flop, present state and next states same only. It is a very small and simpler flip-flop. It is used for acting as a buffer. Buffer means temporary storage location, separating valid address from the multiplexed address. Transceiver. So it is a bidirectional buffer, also called amplifier, transmitting and receiving the data. So used to separate data from the multiplexed address signals. Memory. It is used for storage purposes. IO devices used for communication with the processor. Clock generation. Generate the clock from the crystal oscillator. So this is the block diagram of minimum mode 8086 systems. So already we know that 8086 pin diagram. So it is the 8086 processor, memory slash IO, read, write, bus high enable, address latch enable, data enable, data transmitter and receiver. Okay, so here already we know that it can be divided into 4 different types of component. First one is clock generator. With the help of the clock pulse only, the circuit will be executed. So clock ready state and reset state. One up, one down. It is called a one clock pulse. Four clock pulse. Four T states. It is called a one complete bus cycle. With the help of the one complete bus cycle, the microprocessor to read the data, to decode the data, read or fetch the data, decode the data, and execute the data with four T states. Four T states, it is called a one complete bus cycle. Next one is multiplexing. Memory read, read signal, write signal. So we have to read or write the data. Read data means to give the input from I/O devices or memory devices to the processor. Write operation means after the execution, receive the output from the processor and send back to I/O or memory. So demultiplexing can be used for differentiate memory read and memory write, I/O read or I/O write. So 8086 microprocessor control 15 data bus, 16 address bus. Okay, so here one square shape, it is called one latch. One latch is 8-bit. So address latch enable 8086 processor support 20 address bus. Data enable only 16 data bus. If one latch size is 8-bit. 8 plus 8 means 16. Maximum size of the address supported by 8086 processor is 20. So that's why we need 3 latches. So first square bracket, second square bracket, third bracket. So 8086 address latch enable support 3 latches. So data enable means only 16 data. So one latch is for 8, another latch is for 8. So totally 16 data. Okay. To transceiver. Transceiver means transmitting and receiving the data from memory and I/O. Memory means like a RAM or ROM. To read or write the data through the I/O devices. So here transmitting and receiving the data from memory and I/O devices, that is called a transceiver. Latches means sometimes to read and write the data through the information or addresses. So here this addresses means to get or save the data from the to the address from the memory from the I/O. So during the T1 state, 4 T states, it is called a one complete bus cycle. So during the T1, the first initial clock pulse, the address is placed on address bus or data bus. Control signals, memory, I/O, address latch enable, data transmitter or receiver. Specify memory or I/O. Latch the address onto the address bus and set the direction of data transfer on the data bus. During the T2 states, 8086 issues the read mode, write mode, and data enable for write the data. Data enable the memory or I/O devices to receive the data for write and the 8086 to receive the data for reads. During the T3, so the here cycle is provided to allow memory to access the data. Ready mode. Sample at the end of the T2 states. If low, T3 states become a wait state. Otherwise, data bus is sampled at the end of the T3. During the T4 states, all bus signals are deactivated in the preparation for the next bus cycle. Data is sampled for read, write, occur for writes. So here 4 different types of clock pulse is there. Memory reading minimum read and write from the memory. and IO devices. So here memory read in minimum mode. Next diagram is memory write. The same way we have to draw the timing diagram for IO read and IO write. First is clock. So one up, one down. So here one down, one up. It is called a 1T1. One down, one up. Second T2 states, T3 states, and T4 state. Why? What is TW means? It is called a waiting time states, waiting T states. So here minimum mode means we are giving as the input is 1. 1 slash 1 bar means 0. So we are giving input as 1 acting as a minimum mode. Input as 0 acting as a maximum mode. So input is 1 means throughout the first clock pulse to last clock pulse. So for T state it is called one complete bus cycle. So entire complete bus cycle the minimum slash maximum is 1 up states. Next IO and memory. So here question is memory read operation. So we are giving as a 1 as a input. 1 means 1 bar is 0 slash 1. 1 as a input means it is a memory. 0 as a input means it is a IO. So this diagram is memory read. So entire T1 to T4 states it is a up only. Sometimes the same diagram for IO read means the entire T1 to T4 state is down mode only. Data transmitting or receiving. So here transmitting the data. To receive the data means a write operation. Okay. So transmitting the data. 0 slash 0 bar means 1. So 1 means to receive the data. 0 means to transmit the data. So read operation means to transmit the data. So that's why 0 as a input. So here down states. So here address and selection line. So first T1 states can be used for to find out the address. Then we have to use the selection states. Next address. Address and data bus multiplexed together. First T1 state to find out the address. After that we have to find out the data. If you want to find out the address of the, if you want to be your friend. First, you have to know the address of your friend. If you know the address, you have to find your friend. So that's why here, first T1 state, you find the address. If you know the address, you have to collect the data or operand from the address. Address latch enable. So first T1 state only to find the address. So that part only enable. To read operation, we have to read only the data, not the address. So in this part only we have to read the data. So read bar is there. So that's why 0 down mode. 0 as a input means 0 bar equal to 1 as a read operation. So 0 as a input, 1 as a output. Data enabled. We have to when the data is enabled. In this part only data is enabled. So that's why it is a down mode. So what is the difference between memory read and the memory write? So here in this side, we are transmitting the data means read operation. We are receiving the data means write operation. So see here, up only. We have to write operation. We change the read as a write. Write means after the execution to collect the output from the processor. So here also in this data only. After the execution, we collect the data, not the address. So that's it. Thank you. The similar way, we have to try to draw the timing diagram for IO read, IO write.